Welcome back to my today's session of electromagnetic field theory, and today we are going to start the Gauss Law and its application of Gauss Law. My today's topic will have two sessions. Today we are going for the first session. Myself, Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. So, what is the Gauss law and what is the application? So, from this topic, students will be able to understand the Gauss law for obtaining the electric field intensity, density of uniform and non-uniform regions. So, before starting, let's give a small example, small recap. What is electric charge? Electric charge is the fundamental and the characteristic property of any elementary particles. The electrical charge or electric charge can are two types. One is called positive charge and another one is called negative charge. The positive charge have less amount of electrons and the negative charge has more amount of electrons, more than the number of protons. Now, we know the like charges repel each other and the unlike charges attract each other. What does it mean? If both charges are positive or both charges are negative, they will repel each other. On the other hand, if one charge is positive and another charge is negative, they will attract each other and they always follow the conservation law of the charge. What is the meaning of conservation law of charge? That charge cannot be created or destroyed. Charge in a closed loop is always constant. So let's start the electric field lines. What is the meaning of electric field lines? What is the meaning of field first? Field means the area where if we keep something, it will feel some force. So electric field is basically an area due to some electric charge, and for what? If we keep any charged particle in that area or in the proximity of the area, it will feel some force. Now, what is electric field? The lines of force. Electric field can be represented by field lines. We can imagine, this is completely imaginary, we can imagine that some charges are coming out or coming in and it is creating the field. That some lines are coming out, say if it is a positive charge, some lines are coming out and it is creating the field where the charged particle can feel the force. Now, we know that the charge from the positive charge, we will assume that the electric lines of force is attractive in nature. You can see this is the it will start from positive charge and it will meet in the negative charge. So from the positive charge, what is the nature of the electric lines of force? This is basically the diverging nature, and in the case of the negative charge, we can assume that the electric lines of forces are converging type. And if both charges are present in an area, we can assume that the electric lines of force will start from the positive charge and meet the negative charge. So these are the three important properties of the electric field lines. What are the properties? First one, electric field lines are imaginary lines of force. It will start from the positive charge and it will meet at the negative charge. Third one, in the positive charge, the electric lines of forces are diverging in nature, whereas if we have the negative charge, it is converging in nature. So you can see from the diagram that it is the coming inside and this is going outside. Now, So flux through a sphere. As our universe is basically, assume our mother earth, the total universe is the spherical in nature. So we will assume, if it is not mentioned, the field is basically some spherical in nature. And we can understand, if there is some charge Q, if there is some charge Q, we can assume that the electric field will come from around the point charge and it creates a sphere. And we know what is intensity. Intensity of a field is given by 1 by 4 pi epsilon 0 q by r1 square. What is the r1? Radius of the sphere. And the value of the radius can go up to infinity. What is the range? The range of the radius is 0 to infinity. So this is the radius. So if we are assuming a sphere in a with respect to a point charge, we can write field intensity equals to 1 by 4 pi epsilon 0 q by r1 square. What is epsilon 0? Epsilon 0 is nothing but the permittivity of free space. Next. So, what happens if the number of charges is 2 or more than 2? Let's assume there are, because practically one single charge is not possible. One area, it is full of charges. Let's have, there are a lot of charges in a surface. There is a general tendency of the charge is to reside on the outer surface of any field. In the inner surface, there is no charge. So this is the surface area of any conductor or of any place, and the charges is Q1 by Q2. So for the Q1, what will be the flux density? Q by epsilon 0. If we have more charges, what is the lines of force? Q2 by epsilon 0. Because we are assuming that all the charges are in the same medium. So we can write the total number of charges, we can write as Q by epsilon. So what is the flux? Since the flux is related to the number of lines of flux, so number of lines phi s can be written as Q1 epsilon 0 plus Q2 epsilon 0, like this. And from here we can get the Gauss law. Somewhere the phi s is also written by psi. What is psi? Electrical lines of flux. Now we will come in the case of the flux density. What is the meaning of flux density? Flux density means flux per unit area. What is the meaning of flux density? The electric flux per unit area is known as the flux density, or we can write electric lines of force. Another name is electric lines of force per unit area is also known as the flux density. Flux density is basically a vector quantity. In the case of the vector quantity, we can give the arrow marks or we can write it as bold as we used here. So what is the flux density? Flux density D is equal to psi by S. S is the surface area. As we discussed, the general tendency of the charge is to stay on the outer surface of any conductor. We will take always the surface area. So what is D? D equals to psi by S. Now, as we assume the total thing, the total field is spherical in nature. So what is the surface area or cross-sectional area of the sphere? This is 4 pi r square. So what is Q? Q is equal, what is D? D is equal to Q by 4 pi R squared. Similarly, from the last slide, if we go to the last slide, we can see what is E? E is equal to, we can write E is equal to Q by epsilon 0 4 pi R square. So this is Q is equal to epsilon 0 4 pi R square, and now we got the equation D is equal to Q by 4 pi R square. E is equal to Q by 4 pi R square epsilon 0. So if we compare these two equations, we will get D is equal to epsilon into E. And this is only for the free space. If the space, so this is the relation between the E and D. What is E? E is the field density is equal to Q by 4 pi epsilon 0 R square AR. What is AR? AR is nothing but the unit vector. It gives the direction of E. And what is why the direction is R? The direction is always radially. The direction of E is radially. So if we calculate the D by E, we got the relation D is equal to epsilon into E. Why? Because D is equal to Q by 4 pi R square AR. So if we divide it D by E, we got the relation D is equal to epsilon into E. If the area, if the medium is another thing except the air or free space, we can write D equals to epsilon 0 epsilon R E. So D is equal to epsilon into E. This is the relation between the flux density as well as this is the, what is D? D is nothing but the electrical flux density. This is the electric flux density. And what is E? E is the field intensity. Now, we will discuss the value of D for a line charge. So, whatever we have discussed here, it is for the point charge. What will happen if it is a line charge? Because as an electrical engineer, we have to think about the line. And what is the example of the line charge? This is the overhead lines, underground cables, all are the line charge. So, in the case of the line charge, we are assuming the relation that, what is the relation? The relation is the, in a line, if it is cylindrical in nature. When we are thinking about a line, if you think about a overhead lines like this, what is the nature of this? The nature of the overhead lines is like a cylinder. So, in the case of cylinder, we are assuming this height is L. The length of this is L. Now, if the line charge density is rho L per coulomb per meter. We have already discussed the line charge density in our previous lecture. But here, for to revise, what is line charge density? The number of charge per unit length. Number of charge per unit length. So, what is this? This is coulomb per meter. Coulomb per meter. Now, what is Q? If it is for a small length, so we can write rho L is equal to dQ by dl. What is dQ? dQ is equal to rho L dl. If we integrate it, we can get Q is equal to rho L integration of dl. What is the height of this? The height of this line we are assuming L. So Q is equal to integration of rho L dl. So it is coming rho L into L. Now, the line is not a sphere. Line is basically cylindrical in nature. What is D basically? D means flux density is equal to, we can write number of charge by surface area. Already we have discussed these things. What is D? Actually, D is equal to psi by S. And what is psi? Psi is basically same equals to the number of charge. So what is the flux density? Q by S. What is D? D is equal to, we can write Q by S. D is equal to flux density. Flux density means number of electric lines of force per unit area. So actually D is equal to psi by S. According to the law, psi equals to Q. So according to the law, psi is equal to Q. So we can substitute the Q with the value of psi. So if we substitute the value of Q with psi, we can write D is equal to Q by S. And we are using this formula here. So what is D? D is equal to, we know Q by S, for a sphere it is 4 pi r square. And what is Q? Already we have discussed, rho L dl divided by 4 pi r square. Now, when it is a case of a cylinder, the surface area of a cylinder is given as the 2 pi RL. What is 2 pi RL? R is the radius of the cylinder and L is the length of the cylinder. So we can write that E is equal to rho L into L by 2 pi epsilon 0 RL. L cancel out and we got the equation EL is equal to rho L divided by 2 pi epsilon 0 R. Now what is the relation between D and D? D is equal to epsilon 0 into E. So we got the relation D equals to rho L 2 pi R AR. And this is only for the electrical line charge. This is the special case D due to a line charge. Next, if we want to calculate the value of D due to the surface charge, what will happen? If we want to calculate the D for a surface charge, if it is any surface, we will assume that the Q is equal to rho S ds. What is rho S? Rho S is equal to surface charge density. And what is the value? Again, Q by surface. Now, what is the surface area? The surface area of a sphere is 4 pi r square. So, we can write rho S ds by 4 pi r square AR. AR is the direction of the D along the radius. Now, what is the value of D due to the surface charge? Now we know. So if it is when the charge is infinite, this is the main thing. When the charge is infinite, what does it mean? Charge is infinite means the value of S, the value of rho S is infinite, and here we get rho S by 2 epsilon 0, because when we are calculating the integration, we are giving the limit up to infinity. So D is equal to rho S by 2. Now D due to the volume charge. Similarly, when we are thinking about a volume charge, we know volume charge density is equal to rho V is equal to charge per unit volume, means coulomb per meter cube. So what is Q? Q is equal to, what is Q? Q is equal to rho v into dv. It is an integration. So it is the Q is equal to integration, volume integration. Volume integration means 3 times integration rho v dv. What is E? E is equal to Q by 4 pi epsilon r square. So it is the value of E. Relation between D and D. D is equal to epsilon into E. So what is D? D is equal to rho v dv. 4 pi epsilon 0 cancel out r square. Now, what is the from the electric lines of force we can get the important law of electrical engineering, and that is known as the Gauss Law. Gauss Law is also known as the inverse Coulomb's law, because Gauss Law is used in the reverse Coulomb's law. If we are not writing the Coulomb's law, we can write it as the form of Gauss Law. Gauss Law does not tell anything new. It is not a new law of physics. It is expressed the Coulomb's law in the another way. And what is the Gauss Law? According to the Gauss Law, the electric flux passing through any closed surface is equal to the total charge enclosed by the surface. What is Gauss Law? The electric flux passing through any closed surface is equal to the charge enclosed by the surface. So what does it mean? If we have a closed path and if any charge is inside the surface, the lines of flux will come out. And what is the number of lines of flux? Lines of flux is the surface integral of ds into ds. This we can write it, this bold letter means it is a vector quantity. So d into ds is equal to charge enclosed. If in a field the amount of charge enclosed is equal to q, q is equal to number of psi. What does it mean? If we have a surface and there is, say, one charge q1, another charge is q2, and the lines of flux is coming out. So number of lines of flux is equal to amount of the charge enclosed. Amount of the charge enclosed. So if we want to write it in the vector form, what is the meaning of the vector form? So vector form means, we already told in the previous slide that it is a vector quantity. It is a vector quantity. So D is equal to, if this is a surface and in the surface some charge is there, so electrical lines of force is always normal to the surface. We know if any surface is there, the general tendency of the flux to go in the normal or the 90-degree direction. I have given the example, if we give some fire on somewhere, the general tendency of the smoke is starting go upward. So similarly, if we keep some charges on the ground, the general tendency of the flux is to go upward. So D psi is the total lines of force, ds is the differential surface area, and an is the unit vector normal to this area. We can see from this diagram, that if this is the ds, if the surface is S and it is P, so always the direction of ds is always in the normal direction. We will always take it as a normally. So we can write that ds, the surface area, if the surface is, mathematical representation of Gauss law. So this is the mathematical representation of Gauss law, and according to the mathematical representation of the Gauss law, if q amount of charge is closed by a surface, the surface may be any geometrical shape, may be without any geometrical shape, we can write that there is some lines of force D, and what is the direction? Direction is in the normal to the surface. So if the surface we are taking as the ds. Now what is d psi? D psi is equal to dn ds. What is d psi? D psi is equal to dn ds. What is dn? dn is the normal component of d in the direction of the surface. Now, if the angle is cos theta, what is the direction? What is the normal direction? This will be the d cos theta. So, you can see what is dn? dn is nothing but the d cos theta. So, what will be the d psi? d cos theta into ds, or we can write it d ds cos theta. So if we recap our previous lecture, a dot b is equal to ab cos theta. What is a dot b? A dot b equals to ab cos theta. If we compare these two equations, we can write d dot ds. We can write it as the d dot ds is equal to d psi. If we take integration in the both side, what we will get? If we take integration, d psi is equal to d dot ds along a closed path. What does it signify? It signifies that along a closed path, and this is the Gauss law, number of lines of force equals to the total charge in a closed path. Psi is equal to d dot ds, and this is the mathematical, and what is this? This is the mathematical representation of Gauss law. Now we are coming to the examples of Gauss law. So first we will get the first example. Say you have forgot the Gauss law, what will happen? Nothing, because this is the modified. Gauss law is modified Gauss law, or we can tell Coulomb's law is the modified Gauss law. You can see there are the number of charge q, and the radius of this lines of force, we are assuming an area whose radius is r2. Now, what is the lines of flux? Psi, or we can write like this, q by epsilon 0. Already we have discussed, number of lines of flux is equal to q by epsilon 0. Now we can write what is psi again? E into A is equal to q by epsilon 0 into 4 pi r square. So E dot A is equal to q by epsilon 0. E is equal to 4 pi r square. So what is E? E is nothing but the, what is E? 1 by q 4 pi r square q by epsilon 0. What is Coulomb law? Coulomb law means force is equal to q into E. So what is the Coulomb's law? Coulomb's law, force equals to q by 4 pi epsilon 0 r square, and this is nothing but the Coulomb's law. So this is the first application. From the Gauss law we can calculate the Coulomb's law. This is the reverse Coulomb's law. Next, from the Gauss law we can calculate a line of charge. If we know the line charge density, that is, if we know the rho L, we can calculate the value of the intensity. We can also use it for a rho S and rho V in a case of a sphere. We also can calculate the Gauss law for a point charge Q. So we can use the Gauss law for any type of charge, whether it is a point charge, a line charge, or any surface charge. We will start our discussion with the application of Gauss law for a point charge. How to prove the Gauss law using the point charge. Let a point charge Q be located at origin. So please check this figure. So this is a figure. We are assuming one charge Q is at the origin. X, Y, Z. And we are assuming a charge at Q point. We are assuming a charge at the Q point. And we have to calculate the flux density D when the charge is at the center. When it is not mentioned anything, we will check the Gaussian surface or the surface as a spherical one. And what is the direction of the D? The direction of the D is always we will take as the sphere. So this is the charge Q. This is the charge Q. We want to calculate the D. What is the direction of D? As I told, this is the radial direction. This is the radial direction. This is a sphere. We are assuming a small area P here. We are assuming a small area P here. We have to calculate the flux density in this area P. So first we have to calculate the ds, the surface area of the P. What is the formula of ds for this? This formula of this area is, you can see the radius is constant, the changing value is the d, what are changing? This is the dz. And in case of a surface, the value of the dz is r sin theta d theta. Actually, it is r sin theta d theta. And what is the value of the angle? It is r d phi. This is the radius. In any area, if we have a circle, if it is the radius r and the angle is phi, the surface, the formula of the surface area of this portion is equal to r phi. So here for this portion, the equation is r into d phi, as the angle is d phi. What is the height? Height is the r sin, because this value is the r sin theta. So r sin theta d theta. So what is the cross sectional area of this small chunk? The small chunk area is the r sin theta r square sin theta d theta d phi. You can see ds is equal to r square sin theta d square d theta d phi. If we think that the r equals to a, so we can put here a square sin theta d theta d phi. So what is this? What is the area? Area is now our a square sin theta d theta d phi. And what is the direction of the area? It is always in the radius. So we are writing here a r. Now what is d? We know d is equal to q by 4 pi r square ar. This is the definition of d. That the charge, what is d? D is equal to psi by s. What is psi? Psi is equal to q by s. So number of charge per unit surface area. So d by 4 pi r square ar, q by 4 pi s square ar. d dot ds. And what is, according to the formula, if we multiply d dot ds, we will get d ds cos theta. What is d? D is equal to q by 4 pi r square or q by 4 pi s square. What is s? S we got s is equal to a square sin theta d theta d phi. So if we assume that the angle is 0 degree.
Ma'am, 1 second. Your PPT, what happened?
Oh, I zoomed it.
You zoomed it now, right? Right?
No, so that I understood till that one.
Okay. And like, actually, normally it's our came principles came, and this is like a copy paste images.
They're all are not images. One or two equations are images.
So equations also require some animations. Normally it's our came principles.
So I'll cancel.
No, cancel. Continue this and complete it. Next video onwards, PPT also. PPT only can speak.
Sorry, I can't.
Only PPT can speak.
Okay. I will not write anything.
No, ma'am.
Means animation we have to add.
Yeah.
I am adding animations also, but these are the
And
big equations.
these images also don't paste the images.
Okay. Lines I have written, but the equation I have pasted. Okay. So d is equal to q by 4 pi s square. So what is ds? ds is equal to s square sin theta d theta d phi. So this is the one of the application of Gauss law. So ds is equal to s square sin theta d theta d phi. So the normal to ds is ar. Okay, d is equal to q by 4 pi s square, and we got the ds value s square sin theta d theta d phi. So if we multiply these two equations, what we will get? Q by 4 pi sin theta d theta d phi and cos 0. We will get q by 4 pi s square sin theta d theta d phi cos 0. So what is psi? Psi is equal to d dot ds, and the value of theta is equals to 0 to pi, and phi is equal to 0 to 2 pi. Q by 4 pi sin theta d theta d phi. What is the integration of sin theta? Sin theta integration is equal to minus of cos theta 0 to pi. Integration of d phi is phi, and that it is 0 to 2 pi. So q by 4 pi is equal to minus of minus 1 into 2 pi, and we can write psi is equal to phi, and this is the proof of Gauss law for the point charge. So what is the point form of Gauss law? In the point form of Gauss law, we can calculate the divergence of electric flux density. What is the meaning of divergence? Divergence we write with grad, and it is nothing but the differentiation del x, del by del x by del y plus del by del z. So the divergence of electric flux density in a medium at a point is equal to the volume charge density. This point form is also known, the point form is also known as the differential form. And according to the point form of the law, grad dot d is equals to the rho v. Grad dot d means the divergence of d is equal to the rho v. This is known as the point form of Gauss law. And from here we can write the Maxwell's first equation in the point form. The Maxwell's first equation in the point form can be written as the q is equal to integration of d dot ds. Already we know the q is a surface integral of d dot ds, and if we are writing it is a vector quantity and ds is also a vector quantity. So if we want to calculate the volume charge integral, so what is the value? The value is According to the Stokes theorem, if we want to change the surface to volume, what is the formula? The formula is D can be changed in the grad of D. Grad means del by del x plus del by del y plus del by del z. So D dot ds, del by del x plus del by del y plus del by del z. So into D, into dB. And from the Gauss law, we know the volume integral of Q is equal to rho b and dB. If we compare the equation number 3 with equation number 4, we can get both are Q. Grad dot D is equal to rho b, and this equation is known as the Maxwell's first equation. This is known as the Maxwell's first equation, or the another name of this equation is the Maxwell's equation of in the point form. Next we will discuss about the Maxwell's first equation in the integral form, or we can write it as the Maxwell's second equation. So when we will start the Maxwell's second equation, we will start from the very basic equation of the KVL. If in a closed path we have three voltage V1, V2, V3, we can write V1 plus V2 plus V3 is equal to 0. This is the basic equation of the KVL. Now, we can change the V. What is V? V is nothing but the integration of E dl. E dl, so we can write E1 dl1 plus integration of E2 dl2 plus integration of E3 dl3 equals to 0. So we can write in a closed path E dot dl equals to 0. In a closed path E dot dl is equal to 0. So this is our first equation. Now, according to the Stokes theorem, what is the Stokes theorem? If we want to change the line integral to the surface integral, we will take the grad. And as this is the vector equation, we will take grad cross E. In the case, we will use the cross product. So we are changing the line to surface. This is the surface integral. So E is equal to grad cross E dot ds is equal to 0. So if we compare these two equations, we will get grad cross E equals to 0, and this is known as the Maxwell's second equation. So we can, from this chapter, we have discussed what is Gauss. First, what is electrical lines of force. Next one is the what is electrical field. What is Gauss law? Gauss law means the number of lines of flux is equal to number of charge enclosed. Then we have discussed about the calculation of the flux density, the relation between the electrical flux density and intensity. What is the relation? E is equal to D equals to epsilon into E. Next, we have discussed about the calculation of D for the line charge, surface charge and the volume charge density. Last of all, we have proved the Gauss law for a point charge. And we have discussed the Maxwell's first equation and the Maxwell's second equation. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.